In this lesson, Mod 8 Lesson 2, we're going to be looking at Pythagorean Theorem. All right, Pythagorean Theorem is a relationship that we have with the sides of a right triangle. So when we talk about a right triangle, we're looking at a triangle that has one right angle. The two sides that form that right angle we call the legs of the right triangle. And typically we refer to them as A and B. It doesn't matter which one's A and B as long as it's one of the sides that helps form that right triangle. And then the longest side of the right triangle that is across from the right angle we call C, which is the hypotenuse. So our Pythagorean theorem, we like to use it, describes the relationship of the three sides of a right triangle, and that's a squared plus b squared is equal to c squared, or sometimes we think of it as the leg squared plus the leg squared is the hypotenuse squared. The two sides, again, the two legs of the triangle intersect to form a right angle. Again, a right angle is 90 degrees, and the hypotenuse is the longest side of that right triangle. When looking at a right triangle, we can use Pythagorean theorem to solve for a missing side, right? Because all right triangles have the same relationship, where the leg squared plus the leg squared is the hypotenuse squared. In this first example, we want to label out what our hypotenuse is. Our hypotenuse C happens to be the side we don't know, and the other two lengths, 12 and 5, are going to be the legs of that right triangle. So if we go ahead and put that into Pythagorean theorem, we're going to get, so with a squared plus b squared equals c squared, we're going to be 12 squared plus 5 squared is equal to c squared. We're going to get 144 plus 25 is c squared. This adds up to 169. And then when I square root, I'm going to get 13. So my x is actually 13. That's the length of that part of the triangle. The same thing is true if I have decimals or radicals involved, same concept. So if I label it out, this is my hypotenuse, which happens to be x. That's my unknown, but it's not always my unknown, it just happens to be for this problem. You can make either side A or B, it's not going to matter as long as the hypotenuse is C. So when I put that into Pythagorean theorem, we got 11.9 squared plus 6.1 squared is equal to x squared. 11.9 squared is 141.61 plus 37.21. When we put that together, we're going to get 178.82. And then finally, we have to square root at the very end. And we're going to get our unknown to be 13.4. And that would be the length of our hypotenuse. For the U-tries, we're going to give you a moment to try to see if you can use Pythagorean theorem to solve for the missing side. And here are the worked out answers for the U-try problem. In the next example, we're still going to be using Pythagorean theorem. Again, a squared plus b squared equals c squared, where c is the hypotenuse. It just so happens what we're trying to find is one of the legs, but it's the same concept. So if I look across from the right angle, that's my C. I can call either one of these A or B, and then I'm just going to put that into Pythagorean theorem. So 6 squared plus x squared is 10 squared. 36 plus x squared is 100. And notice your variable isn't by itself, so we have to subtract to get it by itself. So we're going to subtract 36. We're going to get this to be 64. And then when we square root, we're going to get our, the length of our leg is going to be 8. Okay. The next one is very similar, so across from the right angles are C. Again, we're solving for a leg, but the concept is the same. So I got 3 squared plus x squared is 5 squared. 9 plus x squared is 25. Again, our variable isn't by itself, so we have to subtract and then square root. So our x is going to be 4. So now we're going to give you some time to try the next two problems using Pythagorean theorem. And here are the worked out answers to the you try problems. All right, so that wraps up what you need to know for Mod 8 Lesson 2. If you have any questions, you can ask us follow-up questions, or you can sign up for T-Bolt time.